Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today we are discussing about the Bsc Electronics Semester 4 Paper 4 exam strategy. What is the title of the Bsc Electronics Semester 4 Paper 4? The title is Linear Integrated Circuits and Basics of Communications. Linear Integrated Circuits and Basics of Communication is the title of a BSc. BSc means Bachelor of Science, Electronics or studying the electronics. Paper 4. Paper 4. What is the title? Linear Integrated Circuits and Basics of Communication. Right? That exam strategy we have to see. Syllabus and how the questions will come in each and every unit. Those things we will explain in this video. So please utilize this chance. These questions you have to prepare from any book and you will get the more marks. All the best for your success. Right. Once you have to see here, BSc second year semester 4. This is the even semester. Already I told. Already odd semesters, semester 1 electronics, semester 3 electronics, semester 5 electronics papers I told and uploaded in the last semester exams time. This time also even semesters. Even semester means semester 2, semester 4 and semester 6. Why I am not taking the semester 6? Because semester 6 is some DSC papers are there, college by college, teacher by teacher, paper is varying. So that's why I am unable to take that one. Whatever the core is there, core means throughout the Telangana higher education people gave one syllabus. That syllabus is this one. This is the semester 4th syllabus. Right, once you have to see, BSc second year semester 4 paper 4 syllabus title is Linear Integrated Circuits and Basics of Communications. Linear Integrated Circuits and Basics of Communication. Already you know, each and every paper have 4 units. Each and every paper have 4 units. According to your standard, each and every unit consists of 20 marks. Each and every unit consists of 20 marks. If you have to read the perfect in one unit, you will get the 20 marks. Clear? Once you have to check what is your unit number 1, operational amplifiers. Your unit number 1 is operational amplifier. This is very, very important. What is your unit number 1? Your unit number 1 is operational amplifier. What is operational amplifier? Operation through the amplifier. Operation through the amplifier means all mathematical operations, summation, subtraction, division, multiplication, logarithmic, differentiation, integration, anti-logarithmic, adder, subtractor, so on, whatever the mathematical things are there, those things we have to get through the amplifier. Such type of devices we call it as a operational amplifier. Clear? Emitter coupled differential amplifier. One is emitter coupled differential amplifier and block diagram of operational amplifier. Characteristics of a operational amplifier. Operational amplifier parameters: input resistance, output resistance, common mode rejection ratio, slew rate, offset voltages, input bias current, basic operational amplifier circuits, inverting op-amp, non-inverting op-amp as a summing amplifier, subtractor, comparator, voltage follower, integrator, differentiator, logarithmic amplifier. According to your syllabus, this one is there. What is there? Emitter coupled differential amplifier is there. First one is emitter coupled differential amplifier. Block diagram of op-amp, characteristics of op-amp parameters. What are those parameters? How much input resistance is there? How much output resistance is there? Common mode rejection ratio, slew rate, offset voltages, input bias current, basics of op-amp circuits, inverting op-amp, non-inverting op-amp as a summing amplifier, subtractor, comparator, voltage follower, integrator, differentiator and logarithmic amplifier. All these things are there. Clear? Once you have to see the questions from unit number 1, what are the expected questions you have to see. Write a ideal characteristics of op-amp. What are the ideal characteristics of a op-amp? How much input resistance is there? How much output resistance is there? What is the CMMR ratio? What is the slew rate? What is the offset voltage? So these are the characteristics of a op-amp. Some special characteristics are there. Those characteristics you have to write. At least 4 or 5 characteristics you have to take and you have to write. You will get the full marks. For a short question, write a ideal characteristics of operational amplifier. Please remember. Explain the emitter coupled differential amplifier. Emitter coupled differential amplifier, you have to explain it. Explain the voltage follower. Voltage should be follow operational amplifier with a circuit diagram, right? Next, define the CMR ratio, CMRR, common mode rejection ratio, and concept of virtual ground. Op-amp 2 inputs are there now. So one input we have to take it as a virtual ground. What is the concept of the virtual ground you have to give. Define the slew rate and common mode voltage gain. Slew rate and common mode voltage gain. For each and every unit, 5 short questions and 5 long questions I gave. From unit number 1, 5 short questions. These are the short questions you have to read. You will get. First one, ideal characteristics of the amplifier. Second one, emitter coupled differential amplifier. Third one, voltage follower operational amplifier with circuit diagram. Fourth one, common mode rejection ratio and concept of virtual ground. The fifth one is slew rate and common mode voltage gain. Clear? Right. Long questions once you have to see. So many long questions are there in the unit 1, but I segregated into 5 only. Draw the block diagram of op-amp and write its op-amp parameters. First you have to draw the block diagram of op-amp, right? Next, what you have to do? Write its operational amplifier parameters. Operational amplifier parameters. If you read the short questions, you will add in this also. Next, explain the inverting and non-inverting operational amplifier with a neat diagram. Explain the inverting and non-inverting operational amplifier. And with a neat diagram you have to write. Explain the summing subtraction of operational amplifier with a neat diagram. If you have to read the summing, automatically subtractor amplifier also you are able to write. So that one is the third one. Fourth one you have to see. Explain the integrated differentiator op-amp with a neat diagram. Op-amp can act as a integrator. Op-amp can act as a differentiator. So you have to derive the formulas also. Our input what we are giving, input voltage we are giving, output what we have to get. So integrator of the input we are getting, that is the integrator. Differentiator of the input if you want to get, that is the differentiator. Explain the comparator and logarithmic amplifier. Explain the comparator and logarithmic amplifier. 2 I gave. 2 I gave. 1, 2, 3, 4. Total 8 topics are there, 8 applications, and 1 is the block diagram. So these 5 questions from long answer questions from unit number 1. Okay. Once again you have to see block diagram of the op-amp and write its parameter. The second one is the explain the inverting and non-inverting op-amps with neat diagrams. Next, third one, summing and subtractor op-amps with neat circuit. Explain the integrator and differentiator op-amps with neat circuit. Explain the comparator and logarithmic op-amp with neat circuit. These are the 5 questions you have to prepare. So you will get the 20 out of 20 among this unit. Now I am going to second unit. What is our paper? Linear integrated circuit and basics of communication. These are all linear integrations of. Now we learn the op-amps and op-amp varieties also we learn. Now application of the op-amps. What are the application of the op-amps? So you have to see application of a op-amp. So what is the application of op-amp? Sine wave, Wien bridge generator. So sine wave generator is a Wien bridge op-amp. Next, square wave generator. This one we call it as a astable. Square wave generator is astable. Next, triangular wave generator, monostable multi-vibrator, IC 555 block diagram and its working. IC 555 as monostable and astable multi-vibrator. It's a very simple. Once all second unit only itself 5 questions are there. First, sine wave generator, that is the first one. Sine wave generator, that one is a first one you have to see. First one, each one it is sine wave generator through Wien bridge diagram. Through the Wien bridge diagram, you have to do the sine wave. Next, square wave generator. Square wave generator through astable diagram. Through astable diagram, you have to do the square wave generator. Astable operational amplifier. Next, triangular wave generator. This one is the triangular wave generator. The second one. This one is the third one. The fourth one is monostable multi-vibrator. Fourth one is monostable multi-vibrator. The fifth one is IC 555. You are doing in your laboratory. IC 555 block diagram and its working. Next, fifth one is IC 555 as a stable and monostable multi-vibrator. Only how many questions are there? Only 5 questions are there. These 5 topics, it consists of the short questions, it consists of a long question. How the questions will come from the second unit once you have to see. Draw the block diagram of IC 555 and label pins. Block diagram you have to draw with label pins. You have to do the pins. How many? 8 pin diagram it is. IC 555. So which one we have to give to the source, which one we have to give the ground, which one we have to give the input voltage, which one we have to give the output voltage. So those things you have to draw the block diagram and you label it. Next, what are the multi-vibrators? Name few multi-vibrators. What are the multi-vibrator? Astable and monostable multi-vibrators are there. You mention those things. What is astable multi-vibrator and explain it. What is astable multi-vibrator? You explain. Distinguish between the monostable multi-vibrator and astable multi-vibrator. What are the difference between the monostable and astable? You have to write. Explain the triangular wave generator. Triangular wave generator with neat circuit diagram. These 5 questions you have to read. These 5 questions as a short questions you have to read. These 5 questions as a short questions. What is those 5? Once you have to see. Draw the block diagram of IC 555 and label the pins. What are the multi-vibrators? Name few multi-vibrators. Second one. What is astable multi-vibrator? Explain it. Distinguish between the monostable and astable multi-vibrator. Explain the triangular wave generator with neat circuit diagram. These are the 5 questions from short type. Next, long type you have to see. Draw the Wien bridge oscillator and derive an expression for frequency of oscillation. Wien bridge oscillator. Right? This is the first one you have to write. Describe the operation of monostable multi-vibrator using IC 555. This one is a IC 555 application. Your laboratory also you are learning, that one also you have to write. The third one, draw the astable multi-vibrator using IC 555. Describe its operation. This third one also IC 555 application only. Explain the triangular wave generator using the op-amp and give its frequency expression. Triangular wave generator you have to write and frequency equation also you give. Draw the astable multi-vibrator, square wave generator and derive its frequency expression. Right? Only 5 questions are there. The 5 questions I make it. 2 questions IC555 application. IC555 you have to use as a astable multi-vibrator, one question. IC555 you have to use as a monostable multi-vibrator. Latter three question, one is sine wave generator, another one is a triangular wave generator, another one is a sine wave generator, triangular one monostable multi-vibrator you have to write. So these 5 questions for long questions you have to read. 5 questions for long answer. This is the second unit. Please concentrate. Now, I am going to the third unit. This is also linear integrated circuit and basics of communication only. For communication, we need the modulations because my frequency is very low. That's why I am keeping the speaker. So, the speaker will give the sound to the camera, like that. Modulation can take place. Modulation, need for modulation, conditions to need for the modulation, types of modulation, amplitude, frequency, phase modulation. This is the one variety, only single shot you have to read. Amplitude modulation, analysis of amplitude modulation, side bands, modulation index, amplitude modulator, balanced modulator, demodulation, diode detector. This is the syllabus, right? Once again you have to see, one is modulation, introduction, need for the modulation and types of modulations. Next, amplitude modulation is there. In the fourth unit, one more modulation, frequency and phase modulation is there. This is the communication system. First one is a linear integrating circuits and the third unit and fourth unit communication system. Once you have to see the question, draw the waveform frequency of modulation. Waveform frequency of modulation you have to draw. Frequency diagram you have to draw. Waveform frequency modulation waveform diagram you have to draw. What is the modulation index? Explain its significance. Define the modulation index. Explain its significance. If modulation index is more, what will happen? If modulation index is less, what will happen? You have to explain. Define the phase modulation and explain it. Next, third one is the phase modulation. Write the necessity condition for modulation. This is very important. Write the necessity condition for modulation. Pakka question will come. Write the short notes on side bands. This is also important. Side bands. Short notes on the side bands also you have to take. Once again you have to see the short questions. 5 short questions I gave. So these 5 questions for short answer questions. Only 5. Draw the waveform frequency modulation. Waveform frequency modulation you have to draw. What is the modulation index? Explain its significance. Define the phase modulation and explain it. Write the necessity condition for modulation. Next, write a short note on side bands. These are the 5 questions. 5 long questions also I am giving. Explain the analysis of amplitude and frequency modulation. You have to write the formula, derivations are there now. So, those formulas you have to derive for amplitude and frequency modulation. This is the first question. Next, what is demodulation? Explain the operation of diode detector. Demodulation, what is the demodulation? And explain the operation of diode detector. This is one is a second one, right? Third one you have to see, explain the balanced modulator with Nage diagram. You have to mention the balanced modulator with Nage diagram. Fourth one, explain the amplitude modulator and writes its operation. What is amplitude modulator? What is its operation? You have to write. Define the modulation index, side bands and power in amplitude modulation waves. You have to define all the short questions also it will come. This is the for fifth one. These are the 5 questions as a long answer questions. Please remember, only here analysis of the amplitude modulation and frequency modulation, demodulation and diode detector, balanced modulator, amplitude modulator and writes its operation. Next, all the definitions I made as a long question. Clear? So, these questions you have to read. At least 5 questions. If you have to read the long questions, short questions also cover. If you have to read the short questions, long questions also some portion should cover. Next, you have to see this is the last unit. What is the last unit? Frequency modulation and phase modulation, both are there. Analysis of frequency modulation. working of simple frequency modulator, detection of frequency modulation discriminator, advantages of frequency modulation. Up to here frequency modulation is there. Amplitude modulation, frequency modulation transmitters and radio receivers, that block diagram. This is the second part. The third one is introduction to the PAM, PPM, PWM and PCM and delta modulation. These are, how many is there? 1, 2, 3, 4, 5. These are 5 varieties of modulations are there. Over this fourth unit, 3 types, 1, 2nd, 3rd. Okay. So we have to see how the questions pattern from fourth unit. What is delta modulation? Explain it. Last time this question came. What is delta modulation and explain it. Define the terms transmitter and receiver. What is the transmitter? What is the receiver? You have to explain. What advantages do you observe in frequency modulation? In frequency modulation, which type of advantages are there? You have to write. Write about the PAM and PPM. Write the principle of detection of frequency waves. These 5 questions you have to read. These 5 questions you will get as a short answer type. Which type it is? Short answer type. Long answer type once you have to see. Explain the analysis of frequency modulation. Once you are reading the amplitude modulation and phase modulation, frequency modulator, you have to analysis with formula. Explain the frequency discriminator. Frequency discriminator, you have to explain it. Next, draw the circuit diagram of amplitude modulation, frequency modulation transmitters and explain them. Transmitters, you have to explain about the transmitters. Third one. Fourth one, describe the PCM, PWM techniques in detail. These are one also they will ask. Draw the circuit diagram of radio receivers and explain it. These are the 5 questions, long questions from 4th unit. Only 5. Total how many questions I gave? 4 into, for each and every unit I am taking 10. So total 40 questions. If you have to read the 40 questions, you will get 80 marks. 80 marks paper will get within this 40 questions only. Once again you have to see, explain the analysis of frequency modulation, explain the frequency modulation discriminator, draw the circuit diagram of AM, FM transmitters and explain them, describe the PCM, PWM techniques in detail, draw the circuit diagram of radio receivers and explain it. This is the 4th unit. What are the textbooks? Textbooks if you want to follow, because this month is exams are going on. Within the month you are unable to read all the textbooks. You have to take any test paper and you prepare it. Op-amps and linear integrated circuits. Ramakant Gaikwad book is very nice. That book is this much of size is there. You are unable to read. Linear integrated circuit, Roy Chowdhury also nice. Electronic communication system, George Kennedy and Bernard Davis. That book also nice. Principles of electronic communication system, Louis E. Frengenel TMH publications are there. These are the huge books where your library availables are there. Once you go and see, you will get such type of idea. If you have to do the MSc Electronics or further electronic courses, if you have to read, so maybe you will get the benefited from these books. Clear? Now, these are the important questions from semester 4 electronics 4th paper, that is a linear integrated circuits and basics of communication network. Thank you for your watching this one. All the best. So please share and subscribe our YouTube channel. This YouTube channel is your YouTube channel. Thank you so much.